So you'll notice they went ahead and gave you the variables here. If not, you can just create your own variable. So just depending on what you want for a variable. But they did say A is pen, B is pencil. So we already know our variables there. If not, you need to define them. All right. Write an equation that relates the number of pens and pencils Tyrell bought to the amount he paid for them. So the first thing we're going to do is we're going to write an equation for that particular line. So we know that Tyrell bought 4 pens. So that would be 4A. And we also know that he bought 5 pencils. So that would be 5B. And then his total cost for that was $6.71. And so that's what the first equation would look like. For Dahlia, she bought 5 pens and 3 pencils. So her equation looks like this with a total paid $7.12. So those would be the two equations here. The next thing we want to do, solve the system of equations for the price of the pen and the price of the pencil. And so for this, you would have to solve by either substitution, elimination, or actually there's only 2 you would want to do here, not graphing for sure. So I personally would solve for by elimination here because I would not want to have that decimal and all going on with that. So if you want to solve by elimination, you are going to have to get one of the variables to have a positive and negative the same number. One of the variables with a positive and negative the same number. And it doesn't matter which one. So if we just did the first one, we would multiply 1 by 5. Let's say if we're getting rid of A. This has to be a negative 20 here. So we would say negative 4. All right. And so we're trying to get 2 variables that have the same number, one positive and one negative. So for this, you're just going to distribute here. You're going to multiply across. 5 and 4 is 20. 5 and 5. And then when you multiply this, you can just, remember when you multiply your decimals, just multiply them like you would. So you would multiply them out. And then you started with 2 decimals. And so you want to make sure you put 2 decimals in your answer. All right. For the bottom one, we're going to distribute a negative 4. So we have negative 20, negative 12. And again, you're just going to multiply the 4. And then it is negative here. So because I distributed that negative through, my answer is going to be negative. Make sure you put your 2 decimal places there. All right. Once I have that, I can add down. So now that I have this, I can add these and I will have an elimination going on. So positive 20 and negative 20 will cancel. Positive 25 and negative 12 will give me a 13B. And then here you're just going to subtract. Remember subtracting decimals. You're just going to subtract down, make sure your decimals line up, do your carrying and everything you would do here. All right. And make sure you bring your decimal down when you subtract as well. All right. So that's a 7, not a 9. Once you have this, my last step is easy. So I'm just going to take this 13B and I'm going to take my $5.07, right? And I'm going to divide by the 13, all right? And so we're doing long division here with our decimals as well. All right, so if I divide this and divide this, remember you have 13 on the outside, 507 on the inside. You don't have to move decimals if you don't have a decimal on the outside, all right? So then you're just, how many times does 13 go into 50? 3, all right? So it's going to go 3 times. We'll get a 39 there, right? And then just subtract. Bring down your 7 all this wonderful time for... All right, 13 goes perfectly into 117 9 times, right? So that's going to be 117.39. What does that tell us? We solved for which variable? Because I saw this on the quiz. Which variable did I just solve for? Yeah, I solved for B. B is 0.39. That means that my pencils cost 39 cents. And how would I solve for my pens? Plug it back in. So you plug it back into either equation, and you will get $1.19 for your pens. All right. You have $22 in your bank account and you deposit $11.50 each week. At the same time, your cousin has $218, but he is withdrawing $13 each week. When will your accounts have the same balance? And how much money will each of you have after 12 weeks? All right. So we are going to set up an equation for money. This is similar to the second example that we did yesterday. Each of our equations will represent an amount of money. So the first equation will represent your money. Your money is going to equal how much you have in the bank plus how much you are depositing each week. Do we know how many weeks? No, so that's also a variable. $11.50 per week. All right. Your cousin, this one will look like this. His money. He starts with 218, but he is withdrawing. So we're not going to be adding to his account. What are we going to be doing? We're going to subtract, and that is $13 for each week. $13 for each week. All right. We need to first figure out when they have the same balance. That's when they're going to be equal. This is like the break-even point like we did on this example 2 yesterday. If I have it set up this way, this is just like one of your third question on your quiz, right? You have to solve for this with substitution, all right? So I am going to take this and set it equal to that. If they both equal y, then they equal each other. So I have 22 plus 11.5x equals 218 minus 13x, all right? Okay, so far so good. So when I'm solving something like this, I'm going to get all my variables to one side, all of my numbers to the other side, and then I'm going to divide. So I'm going to get my variables to one side, right? Not 13.5, 13.0. Make sure you line up your decimals when you do this. This is another problem I see with decimals is that you add it over. You have the 13 not lined up. So you want to make sure if you have to, put a 13.0 and add down. All right, 24.5x. And then move all your numbers over. All right, move all your numbers over. When you divide, you don't get a whole number here. They rounded, they must have rounded here when they did this, because when you round, you're going to get 8 weeks. When you round, you're going to get 8 weeks. I will say, how much after 12 weeks, you're going to plug a 12 in here. That's how much you'll have. Plug a 12 in here. That's how much your cousin will have. All right, after 12 weeks. This one right here. So, number 7. A family is canoeing downstream. That is with the current. Their speed relative to the banks of the river averages 2.7 miles per hour. During the return trip, they paddle upstream against the current, averaging 1.5 miles per hour relative to the riverbank. Write an equation for the rate of the canoe downstream. Write an equation for the rate of the canoe upstream. Solve the system to find the family's paddling speed and find the speed of the current. All right? So, if they are traveling with the current, do we add their speed in the current or do we subtract if they're traveling with the current? Is the current helping them or hurting them? Helping them. So we are going to say that, we'll just say if X is the canoe, right? And then Y is the stream, right? Then we would say X plus Y, how fast they're canoeing, plus the stream, the current, should equal what they averaged. So what did they average when they were going with the current? 2.75. Well, then if they're going against the current, we're going to have to subtract it because the current is hurting them. So we're going to say X minus Y is going to equal their average when they were going against the current. So there's your two equations, downstream and upstream. Solve these. So they want you to solve for both X and Y, basically. Solve the system to find the paddling speed in still water, so how fast they were paddling. Find the speed of the current. And that's what they want you to do here. You already have this one set up. I would not solve by substitution here. I would solve by elimination because I already have them set up with a plus and minus. So I'm going to just add those. This will cancel. I get 2x, all right? When you add these, line up these decimals here, all right? Line up those decimals. So when you'll get 4.25 5 there, 4.25 when you add up your when you line those up and add. And then your last step to find x, which will give you their speed, is just to divide by 2, right? Divide by 2. And I don't know if they rounded this or not. I don't think they did, but their paddling speed was 2.125, 2.125, right? And then to solve for the other one, I just plug it into one of these. I just plug it in. So if I plug it in here, then I would say 2.125 plus y equals 2.75. Again, pay attention to your decimals. 2.125, you want to add a 0 here. All right, and so when you subtract, you'll get 0.625 for the canoe. And 2.125 for the canoe. And this is for the stream. There we go. So this is for the current. This is still water. All right. Is we want to talk about inequality. Inequality. We have done inequalities on the number line, all right? So we all know what this means right here. X is less than 1. You notice there's an open circle because it does not include the 1. And we graphed everything to the left, all right? We graphed everything to the left. On a coordinate plane, x is less than 1 rather. There would be an entire line here at 1. And we would shave everything to the left of the line because now we're talking about x's and y's, not just x's, all right? And so when you graph on the coordinate plane like this, we're going to graph the line and then we're going to decide if we shade above the line or below the line to determine what we're representing for our answers here. So a linear inequality, here's at the top of page 371, describes a region of the coordinate plane that has a boundary line. All right, so we have a boundary line here, and it has solutions. So solutions can fall above the line or they can fall below the line. If it's a vertical line, it can fall on the left or right. They've given us 2 examples here. The first one's y is greater than x plus 1. You'll notice that it's just greater than, it is not greater than or equal to. So they graphed the line x plus 1. They started at 1, and then their slope was up 1 over 1, right? So they went up 1 over 1. So they graph this line, but you'll notice the line is dashed, right? We have a dashed line. This is equivalent to an open circle. This is when you only have greater than or you only have less than. So you are telling me by dashing this line that it actually doesn't include the line itself, right? That's just the border or the boundary. They also have greater than here. So we look at the y, the point on the y, and we're going to shade everything where the y gets bigger because the y is bigger than this graph. And so whatever side of the line that the y is getting bigger on, that's the side of the line you are going to shade here. All right, shading is how you're going to show me this answer. Look at the other example they gave us. The other example over here is y is less than or equal to 2x plus 4. Less than or equal to. All right, so they started at 4. Negative 2x goes down 2 and over 1. Down 2 over 1, right? So they graph this line. This line is solid, all right? It is solid because we have an or equal to, And then y is less than. So we start at the 4 where we cross the y, and we're going to graph the side of the line where the y is getting smaller, where it is smaller. And so this is why we shaded all of this. All right, so that is a linear inequality, So let's do one of these. They want us to graph y is less than 2x plus 3. All right, less than 2x plus 3. We always start with our y-intercept, which means we start on the y-axis. So we are going to find positive 3 on the y-axis here, which will be right here, positive 3. From that, we will use our slope. Our slope is 2. Now remember, if it's a whole number, we can represent it by 2 over 1. That means we can do 2 over 1 or negative 2 over negative 1. So we can go up 2 and right 1, or we can go down 2 and left 1 from our starting point. All right, so we start here, we go up 1, 2 over 1, and we can plot the point right there. Or we can go down 2 and left 1, and we can plot the point there. And that will give us this graph here. All right, and then once we have those, we're going to connect our dots. Now, this is just less than. just less than. So since we don't have an or equal to, we want this to be a dashed line. So we are going to do it dash. That indicates that we do not have an or equal to. All right. And we have graphed our line here. The next thing we're going to do is we are going to decide if we need to shade above or below this line, which side. And so for that, we are going to look at the less than sign. We know it's not or equal to, so we dashed it. Less than. So we are going to start on the y-axis, and the side of the graph that where the y is getting smaller, that's where we're going to shade. And so we are going to shade below this line here. Let me change it to shading. Below the line here will be our shading. And that whole graph will be our answer. That whole graph will be our answer. All right? So go ahead and check your work. For this one, your y-intercept is -1. So you're going to start on -1 on the y-axis. Your slope is 3 over 1. So you're going to go up 3 and right 1 or down 3 and left 1. And then it's or equal to, so we're going to do solid and above for greater than. All right, so there may be times when it is not in slope intercept form. We actually will graph using intercepts, x and y intercepts for the next one. But there are times when it's easier just to get it in y-intercept form, especially if your y-intercept is going to, or slope intercept form, especially if your y-intercept is going to be a whole number when you do it. All right. And so for this one, I have 3x minus 5y is less than or equal to 10. Sometimes it's hard to tell which side of the graph to graph on when it looks like this because you don't have your y by itself. And so a lot of times it's easier just to go ahead and get that y completely by itself, and then you can graph it. So if I take the 3x minus 5y is less than or equal to 10, this is what you did for bell work. We will subtract the 3x from both sides, all right? Over here, we're left with -5y is less than or equal to -3x plus 10, all right? And then I am going to divide by -5, all right? Dividing by -5. Now it gives you this little reminder in your book right here. Multiplying or dividing an inequality by a negative number reverses the order of the inequality. So it flips your greater than less than. So when you do this, divide by the -5, divide every piece by the -5, you'll get y, and you have to flip this. Greater than or equal to negative divided by a negative is a positive. And then 10 divided by -5 is -2. So I now have it in slope intercept form, but you can see at the beginning, if you just took this one, you may have thought that you would be graphing below the line here. But when you put it in slope intercept form, you can see you're graphing above the line, all right? And so you're going to graph exactly the same. We're going to start at -2, up 3, and over 5. Or again, you can go down 3 and over 5 as well. All right. But either way, you're going to connect your dots. This is a solid line because it's or equal to. And then now that we have done this, we can see that we are going to graph above the line. We're going to graph above the line. All right. And so we're going to take this and we're going to shade above the line here. All right. So go ahead and try check understanding number 2, bottom of page 371. So check your work. 3/2 is at 1.5. Again, just estimate that. So when you do your slope here, you're going to fall somewhere in between 2 points, which is fine. Connect your dots. It is a solid line because it is or equal to. This one did not flip because we did not divide by a negative. So we just do above the line here. Everything's shaded above the line. For your party allows you to spend no more than $12 on peanuts and cashews. Peanuts cost $2 a pound. Cashews cost $4 a pound. Find 3 possible combinations of peanuts and cashews that you can buy. You'll notice I just have the first quadrant here because you can't buy a negative number of peanuts and cashews, all right? So when you have a word problem, very often you only need your first quadrant, all right? So for this, maybe we will just say X then is peanuts, and then we will say Y then is cashews, all right? And so make sure that you label them if you set up your own variables. And then you're going to set up your equation. $2 a pound, so 2 times X, plus $4 a pound, that's 4 times Y. And it says no more than, no more than. So is that going to be less than or greater than? Less than or equal to. If you can spend no more than this amount of money, that needs to be your highest value. So we're going to say less than or equal to. No more than means it could equal 12. All right. Now in this situation, in word problems, I very often use my method of intercepts here. All right. So with intercepts, I would just zero out my Y and I would get 2X equals 12, X equals 6. So that tells me that my X intercept is right here at 6. All right. For my Y intercept, I would zero out my X and I would get 4Y equals 12. So Y equals 3. And so that tells me my Y-intercept is here. And so now I have a line based on those 2 intercepts, and I can just connect those. Now, when I'm doing intercepts, you have to look at the sign in front of your Y. The sign in front of my Y is positive. This means if I were to put it in Y-intercept form, my greater than less than would not change. All right, it would not change. So I can use the less than here. If it were negative, remember it would flip. All right, but it's a positive in front of it. So I can use less than or equal to, which means my region of my options here is going to fall in this little triangle. These are all my combinations of peanuts and cashews that I can buy. So if they want me to pick 3 options here, then I could pick any 3 numbers. Obviously, you want to pick whole numbers here, but any 3 of these would work. So 1 pound of my peanuts and 2 pounds of my cashews, or 2 and 2, or I could say 3 and 1. You can pick one that falls on the line if you want to. But any of those would work. Those would be valid combinations of what I could purchase based on my budget. So that shaded region gives me the answer. It tells me what I can use, what are usable numbers based on the information that I've provided, based on the limitations I've provided. Let's try one of them. Bottom of page 372. So check your work. If hamburgers are $3 a pound, 3X. Chicken wings are $2.40 a pound, 2.4Y. That's less than or equal to what you can spend, which is 24. Zero out your 2.4. 24 divided by 3 is 8. Then zero out your 3X. 24 divided by 2.4 is 10. And then mark those. So my 8 is my X-intercept, my 10 is my Y-intercept. So you could have picked any combination in this shaded area.